Alrighty, welcome back. So, for this example, we are going to visualize and analyze this power balance for the circuit. So, this question specifically wants us to verify that the interconnection satisfies the power check. So, what is the power check? Let's remind ourselves the power check means that the sum of the power absorbed plus the sum of the power generated must equal to 0. Alright, so in order for us to say that this interconnection satisfies the power check, we must show that all the power absorbed plus all the power generated equals to 0. So let's go ahead and do that. Now, being critical thinker, we're going to look at what we're given. We are given a circuit where we have our voltage polarity defined for us. We have our current direction defined for us for each element. Now, looking to the table that they give us, we are only given power and current. Now, what is the missing puzzle piece? Well, it's voltage. How can we solve voltage? Well, it's just a simple algebraic manipulation from the equation power is equal to VI. Well, V will equal to our power divided by our current. So let's go ahead and write that equation in just so we have it. Power will equal to VI, therefore voltage will equal to my power divided by my current. So let's go ahead and take this element by element. Now, let's start with element A. So the power for A, let's start with passive sign convention, writing that first. So my power for A, I see that I have a voltage drop because my current is entering my positive terminal and going towards my negative terminal. So by passive sign convention, to obey it, I'm going to call it a positive V times I. Now power B, my power B is going to be similarly a voltage drop. My power for C is going to be a voltage rise. Why? Because I'm entering my negative terminal and exiting my positive. Therefore, I have a negative passive sign convention. So I'm going to have negative V times I. Power D. Power D is going to be a voltage drop. Why? Again, to obey passive sign convention, positive to negative. Now, it might seem annoying that I'm constantly reminding myself positive and negative, blah. But it's good because it drills into your head that you should always be watching out for passive sign convention. Otherwise, no matter what you do in your circuit, no matter how you write the equations and solve them, it's not going to be correct. So you have to obey passive sign convention. So let's build that habit early, okay? Now, my power through E, I'm going to have a voltage rise. So I'm going to write my negative V times I. My power through F. My power through F is going to be positive V times I. My power through G will be positive V times I. Now, like I said before, we were ahead of the game, so we identified that we're missing voltage. So, keeping in mind our same passive sign convention, we need to solve for the value V to satisfy this interconnection. Alright, let's do that in another color as well. So, in order to do this, like I said, power will equal to, V will equal to power over our I. And also, let's take a look at our units. So, when we're doing this, I notice that we have something in megawatts and we have something in milliamp. Now, this is times 10 to the power of negative 3, all right? Now, because we're dividing, we have milliwatts divided by milliwatts. They're going to cancel out, okay? So, we don't need to worry about converting them yet. So let's go ahead and write this through, keeping in mind our same passive sign convention. So my voltage A will equal to my power divided by my I, and this is a positive. My VB will equal to a positive power value divided by I. My VC will equal to my negative, from my passive sign convention, that's important, my negative power divided by my I. My VD will equal to my positive P over I. My VE will equal to my, again, negative by passive sign convention. It's going to be negative P divided by I. My VF will equal to positive P divided by I. And my VG will equal to my positive P over I. So let's go ahead and substitute these values. My VA is going to be, once I solve everything, my voltage value for A will be a positive 7 volt. My VB will be a positive 5 volt. My VC will be a positive 3 volts. My VD will be a negative 8 volt. My VE will also be a negative 8 volt. My VF is going to be a negative 4 volt. And my VG is going to be a negative 12 volt. So, keeping this in mind, ask ourselves, do we have enough information to compute power with passive sign convention in mind? Yes, we do. All right? So, let's go ahead and substitute our values in. Let's make a little partition. All right? And we're going to switch to a smaller pen. Alrighty, so we are going to write our power. Now, my power for my A is going to be positive VI, so it's going to be 175 milliwatt, and units are super important. And like I said, before I wasn't paying attention to units simply because we were dividing and the units cancel out. In this case, I have to be super careful because they are not going to cancel out. Sorry about that. This jump is going to be 175. My power A is going to be my VA, which is going to be 7 volt, multiplied by the current, which is 25 milliamp. So that's going to be 25 times 10 to the negative 3. My power for B is going to be a positive 5 volts multiplied with the current value that they provide us, which is going to be 75 milliamp. My power for C is going to be my 3 volt positive multiplied with the negative 50 milliamp. My power for D is going to be negative 8 volt multiplied with my 40 milliamp. Power for E is going to equal my negative 8 volt multiplied with the 20 milliamp. Power for F is going to equal my negative 4 volt multiplied with the negative 30 milliamp. And power for G is going to be my negative 12 volt multiplied with 55 milliamp. Now, let's move to another page. So, the values that I get are PA equals my power for A will equal to 0.175 watts. Power for B is going to be 0.375. C will equal to 0.150. Power for D will equal to negative 0.320, and these are all watt, mind you. Power for E is going to equal 0.160 watt. Power for F will equal to 0.120 watt. And power for G should equal to minus 0.660. And we should write power. Alright, so summing all of these values should give us 0. So we have enough information to say that yes, this interconnection is valid. Alright, and let's just make sure we satisfied all the questions. So, show that the interconnection satisfies the power check. Just did that. Identify all the elements that absorb power. We have not done that. Let's go ahead and do that right now. So, again, from our previous video, we can tell this by the value of the sign for power. So, I'm going to say that absorb, we'll get an A, and generate, I can't spell today, that's fine. We'll get a G. So, because I have a positive value here, I'm going to have an A, I'm going to have an A here, I'm going to have an A, I'm going to have a generate, I'm going to have an A, I'm going to have an A, and I'm going to have a generate value. So, now I've successfully shown that these elements are absorbing, these are generating, and the sum of them equals to 0, making the power balance correct. And lastly, we have found the values for the voltage with the respective polarities. All right, so this was a pretty loaded example. I hope you were able to grasp the information and you agree with my solutions. Have a nice day.